they heard that.
They did hear that.
Oh.
Say hi.
Hi, Miss Split's kids. Wait, they're gonna watch this today?
Today, 4th block.
Oh,
Yeah.
If you have friends in Miss Schlitt's 4th block class.
Ben's in that class.
Hey,
Hey,
Miss Schlitt's
Ben!
4th block class.
She is 6, so we're doing what we can. Okay, last chapter you learned how to graph quads. Well, you learned it first chapter, and then we did it again. Today we're going to learn how to generalize that and be able to graph anything in the world, as long as it's polynomial. What?
I stabbed.
So we're going to talk about a few things first. And how we figure it out. The first thing is end behavior. And we're going to fill in this lovely chart. I'm going to draw a picture and probably mostly draw a picture and maybe a little bit words in each box. It doesn't necessarily need to be huge.
Okay.
Morning.
Good morning.
Notes?
Yep. Recording for Miss Schlitt's class today, 4 o'clock. She's 6. So we've got an iPad there, right? We're recording this so that Miss Schlitt's class can
Hi,
do
Miss
it.
Schlitt's class.
They're gonna have so much of
If
that.
I could pan it, I would.
If you could what?
If I could pan the camera.
But we're too worried it wouldn't
Yeah.
work then.
We'll break it. If you guys have any questions, just ask.
Just ask.
Just ask.
Super's gonna like be giving them subliminal messages the entire time.
Probably.
Hello guys.
So basic. ASMR.
What we did here.
Because I'm sure there's gonna be times like they couldn't hear me because I was too far away, and like Cooper's just gonna whisper it. What happened was. Good morning, Mr. Bell. Morning. What you're going to learn here is that if you know 2 things about your equation of your graph, then you can figure out your end behavior. So what it's doing on the left and right, up and down, whatever it is. Those are your limits that you put into your graph. Okay? The 2 things you need to know is what your leading coefficient is and what your degree of your polynomial is. How do you figure out your degree?
Just look at it.
The biggest exponent, the number at the top.
Yep.
Okay? If that biggest exponent is even, what that means is your graph, the end behavior will be going the same direction. Okay? So this will be going, you don't have to write this, but I'm going to draw it in there too. So if you didn't have enough space, don't panic and
Don't
erase
have to write
everything.
that.
Okay? If it is an odd degree, it will be going opposite directions. Okay, and what I want you to think about, even degree would be like a parabola. Do the ends of your graph go the same way? For a parabola? Your x squared? Yeah. Odd degree would be a line. Do the 2 ends of your graphs go opposite directions? Okay, so that's what this is talking about. To figure out where it goes, you need to know if your leading coefficient is positive or if it is negative. If your leading coefficient is positive, where do you think your even degree graph is going to go?
Up.
Good. So whatever your graph is, it could be doing a lot of different things, but both ends will be going up. So here always the limit as x approaches infinity will be infinity. And the limit as x approaches negative infinity will also be infinity. They will both go up every time. If it is negative, where will it go? Yeah, we'll go down this time. again, however many terms it wants to have, but if it is an even degree and it is negative, both as x goes to positive infinity, it'll be going to negative infinity, and as x goes to negative infinity, it'll go to negative infinity. Cool?
Cool.
Cool. For your odd degrees, that means your biggest exponent is 1, 3, 7, 17. I don't care as long as it's odd. They will be going opposite directions. If it is positive, it's like if it has a positive slope. So it will still be going like up to the right, just like a positive slope on a line. So here the limit as x approaches infinity would be infinity, and the limit as x approaches negative infinity would be negative infinity. So one will go up, one will go down, and it's like it has a positive slope, so it's going up to the right. Negative's just going to flip that. That's really pretty. Good job, me. Okay. As x goes to positive infinity, it'll go to negative infinity because it's going down. And as x goes to negative infinity, your graph will go up, so it'll go to positive infinity.
I just drew an 8 instead of an infinity.
You just drew an 8 instead of infinity? It's okay. I think you'll be able to figure out later what that was supposed to be. Okay, so you can figure a lot about your graph just from knowing your degree and your leading coefficient, whether it's positive or whether it's negative. Cool?
Epic. It is epic.
Next thing we're going to talk about is zeros and multiplicity, which we've already talked about. We're going to talk about it again. Really fun.
What the word?
Yes, your biggest exponent, but yes. Okay, for your zeros, this is where the graph hits the x-axis, as you already know. These are zeros, intercepts, roots, whatever you want to call them. What multiplicity does, okay, it tells you how the graph hits the x-axis. Oopsies, that's not how you spell axis. What is multiplicity again? From yesterday, when you solved your equations, what did the multiplicity part tell you? You wrote like mult2 or mult3 or... Good, so if you solved an equation, you got 1 3 times, it had a multiplicity of 3. If you solved it and got 1 2 times, it had a multiplicity of 2. What's going to be important here, if you have an even multiplicity, so that means you get that answer out an even number of times, so 2 times, 4 times, 6 times, whatever it is. The graph will touch the x-axis, but not cross it. It will turn around and go back the other way at that point. So for example, to draw you a picture of that, I'm going to draw a random graph and it's probably going to share with you. That's really good. That point right there where it touches the x-axis but does not go through would have an even multiplicity. So maybe that answer, if it's -1, it has a multiplicity of, say, 2. You would solve that equation, you would get out that -1 twice. If it has an odd multiplicity, the graph will actually cross the x-axis. So this other point over here where it goes through, that would have an odd multiplicity. So even means it touches and turns around.
Didn't you change it?
You're okay. I was mostly laughing at Cooper, who was asking 4th block if I was
Can they
allowed to
see
change
me?
it. We're gonna come
Yep.
back there and be like, no, it was too
Yeah.
fast.
Because,
Yep.
cool.
Too fast.
All right, they're good.
They're good. Thank
Yeah.
you for having the time machine to go ask that. Holly's not, so I'm gonna keep waiting. Holly's good now? Good. Yay! Okay, relative extrema. Oh, got it. This is cross-curricular English class now. Welcome.
Seems like something Neil deGrasse Tyson would talk about. Relative extrema.
Relative
Space.
extrema are turning points of your function. Somewhere that it turns around and goes the other way. The relative part means it's not necessarily the actual highest or lowest points, but they are in that region the highest or the lowest points. So they're the extreme values in some region. So this is the highest or lowest points in a region of the graph. These will always be turning points. Not always, most of the time. Nothing is always, let's be real. Yeah, but nothing's always true. You just have to get to high enough math to learn that. Still, I think.
So 1 plus 1 isn't 2?
Always, it totally is always true. Okay, so here I have both a relative max and a relative min. They are not the actual highest point on the graph, but they are the highest point in that nearby vicinity. Where would my relative max be?
The first turn.
This first term right here, good. This would be a relative maximum. Again, not actually the highest, these points are higher over here. But this is a relative, in this region, it is the highest point, everything else is lower than it. What would this one be then?
Relative minimum.
So that is just talking about in general. Extrema means mins and maxes and whatever. There are extreme values in that section. Now, it makes it sound way cooler than it actually is.
What?
But it's kind of underwhelming.
Relative extrema?
Relative extreme. Because it just means your max and your min.
Sounds like something to do with space.
It probably is. Yeah, we'll go with
Yep.
it. Definitely.
Obviously.
Wait, why isn't the arrow the max?
That would be your so because it's going to infinity, you're going to get in an argument with math people that there is no infinity, and you'll always find a larger value. So there is no absolute max. That's why it's just a relative max. Does that make sense? Can I change it? No one seems to be furiously writing. Okay, we are going to sketch some graphs with some given information about this, and then I'm going to teach you how to find the final piece of actual information you're going to need. You might want to graph a piece of paper, but you're not going to need the whole chart, because right now I'm just going to give you a list of information, and you're going to sketch me something that has those characteristics. Good, thanks guys.
How come you have to tap on it for it not to be blurry?
I don't know. Because it hates me. I think that's why.
It just does it.
The long answer.
Just does that thing.
Do that thing. Logan, you want to get me a piece? You guys need a piece? Logan, get this class pieces too. He's getting you graph paper. I want to know who's in this class. I don't know. Ben is.
Hey guys, we're taking a break to tell you to get graph paper for the next section. I got Cooper graph paper.
Do we have an infomercial because we're on a break?
Logan can make something. I just come up with
Infomercial, go.
Infomercial, go. No ums.
For We're already out of time, guys. We're already starting.
Sorry, it's really fast.
Welcome back.
That's all I had to say.
What's up, Ben?
Do we need
Shout out to my guy Ben.
No, you're not gonna
Shout
do
out to
that.
Ben,
You
fourth
can
block.
just use the actual like graph
Pretty
cards,
cool
yes.
guy.
So I would write down that list of characteristics so that you have it.
Oh,
So that's going to be what's given to you, and you are going to sketch me something that might create a graph like that.
why is there characteristics?
Yeah.
I'm going to
That-
give you some steps. Yes.
Those things.
Yeah.
Three.
Either 3 or 4. Kind of depends on how wordy I get. Probably 4.
It's gonna be 4 steps.
Question will come because Ms. Schlitz notes might be a little different. So they're going to have like 3 lines for steps where where do I put the 4th line? I don't know. Somewhere.
Wait, so we don't need this?
You don't need the
Think
chart,
if-
no.
if the
You can use the
comic
graphs on
only
both
whispered,
sides.
I would watch that like without the mouth. His voice is so soothing.
First thing I do every time is I figure out my end behavior. What 2 things are you going to consider for your end behavior?
Even or odd degree and then negative or positive leading coefficient.
Good. So I'm really here. On this one, I was looking at A and B. Yeah?
Yeah.
Stalling, so you can write.
Get that booster.
Since this is an even degree, will the ends of my graph be going the same direction or opposite direction?
Same.
Same. Since it is negative, will they be going up or down?
Down.
Down. So what I do, and these lines might not connect when you're done, but I just make myself little arrows so I know both ends should be going down. I just make myself a little note so I know where it's going to connect to. Then I figure out my zeros and their multiplicity. So whether it crosses or just turns around. Where are my zeros at?
-2 and 3.
Good. So I go to those points. This is from C and D. I go to -2 and I put a dot. And I go to 3 and I put a dot. Will my graph cross at those points or just touch and turn around? Good. Figure out also for your multiplicity if they cross. Do you agree both will cross?
Yes.
Okay, they won't all both cross, but since these are ones, those are both odd. So at both points, it will go through the x-axis. Your imaginary solutions mean a lot of different things depending upon the function. So we're just going to talk in generalities about what it will do. If you have imaginary, it will always be an even number of them. So it will always be 2 or 4 or 6. And the reason for that is you had to do quadratic formula, and so you had to get 2 different answers there with your plus or minus in your quadratic formula. Okay? What this means, your graph will turn somewhere, but not hit the x-axis. Okay, and because there's 2, usually it will turn 2 times. Sorry for adding that in late. You can all have a space there. I'm going to show you how to do that. You get to pick wherever you want to put it though, because it doesn't tell me anything about where it is.
Wow.
Wow. Later I'll teach you how to find where it is. but-
Use your imagination.
Okay, then you're going to sketch it, keeping everything in mind that we've talked about. The fact that I have an imaginary, where my end behavior is, and whether my roots cross or not. Okay, I just pick one of my arrows. So I'm gonna start here, okay? For my imaginary, what this will look like, and you can put it literally anywhere you want, but your graph will turn around somewhere. So like that is my imaginary solution. Okay, then my graph went through at -2, it went through at 3, and it has a negative even end behavior. Done.
I don't like that.
You're playing connect the dots. It's like a really cool math version of connect the dots. Yes, sir.
How?
Which part? Good with end behavior.
The thing that's like squirrely.
This thing?
Yeah.
Hey, I was-
So this is my imaginary solution. So because
I
of
want to see the
this, it
function
has
that
to turn
connects
somewhere.
a beast like that.
But it does,
So,
so you see how it
twice.
turns and it doesn't hit the x-axis?
Yeah.
That's what's important. So like this doesn't give me an extra answer up here. So it turns.
So could it turn on
You
the
can
other
put it over
side?
here, you can put it up here somewhere.
Okay.
You put it anywhere, you don't know where it is.
So like when you grade it, you just have to have a little squiggle.
Yeah.
When I teach you later how to actually do it, you'll do it for real then. But if I give you just this chart, you have no idea where it's at, right?
What would happen if you only had one imaginary solution?
You won't.
You won't.
Because of your quadratic formula and that your imaginaries come from your radical, and there's always a plus or minus in front of that radical.
Oh, so it's
So you
always
would
a
have
plus or
plus
minus.
or minus it, yep. So you will always have 2 or 4 or an even number, whatever it is.
You guys
They
hear
can't
that?
see that.
They can't see that?
No.
This, you want to pan over to that for them?
Yeah.
Oh goodness, oh goodness.
Gosh, no. There you go. That's all
Well,
she
they
did.
pan. Graph me this one.
That's all she wrote, folks. We have cameramen working furiously. Alright, I got this one. I got it. It's all me.
Richard's birthday today. He doesn't have math today. Brooke, you don't have math on your birthday either.
I was lucky to have a test on my birthday. You guys are not that lucky.
Probably makes sense because it'll be due Monday, so.
Yeah, I always wait till Sunday.
To do it so you have fun. I don't want you to not have fun on your birthday. If you don't have math, how will you have fun? Close, thank
Ask
you, all the way.
myself that
Have fun
question.
without math. Okay, write this one down and give it a try and see how it goes. We'll finish it together in a second. I like to draw your arrows for your end behavior. Figure out where your zeros are. Do they cross? Do they not cross?
Okay.
Both of you the same. Okay, ready. You're talking yourself into the math.
I know how to do this. I got that right.
That's your hint? Is it positive?
Oh, dang it, I did negative. So I did it backwards.
But your 4 is, yeah, so if you had a negative, that's fine.
Mhm, okay.
Do you know what I mean? If my directions had said negative, yours was perfect. Yeah, Bill.
Oh.
Where are my zeros at?
43.
3 and 4.
Yeah,
It says
whatever.
4 first.
Will they both cross?
No.
No, which one crosses?
3.
3, so that has an odd. Okay, the 2 will not cross at 4. Okay, so that'll like rebound and go back around. Okay? Do I know anything else? No. So from there, you just get to have your best guess at what it might look like. Again, I'm going to teach you later how to start finding the stuff so you can know what it actually looks like. But you don't know a lot about this graph. If we draw this, so you can absolutely start from this arrow, or if you get to this point, you're like, that arrow is far too far away, you can totally move it in. Okay, that is just up to you. When you draw this, you know it'll go through a 3, it'll turn around and go back to 4, and then go back up forever. You do not know like how tall this point is. What would this point be?
Relative max.
It would be a relative max. So it might be here, it might be up here. You have no idea. You just have to place it somewhere for now. But that is what this graph might look like. Part of the reason I show you this first is so that while you're graphing your problems later, we're going to graph next time with actual numbers, you'll know how to check if you're right or not. Because if you know if it's odd and positive and your graph is going the other way or your both ends are going up, you know you're wrong. Okay, that's a way to check it and make sure you're good. If you have a multiplicity of 2 on one of your zeros and you have it going through, you're wrong and you can check that and make it go the other way. Cool?
Wait, can you just go back over what A and B mean? Like, towards where your graph is going?
It's the
Yes,
chart
so
that
if
you
it's
drew.
an even degree, they're both going up or they're both going down.
Oh,
Still
okay,
no coffee.
okay.
Yeah. If it's an odd degree, one's up and one's down. Positive means it goes up to the right, negative means it goes down to the right, just like your slope would. Other questions? A lot of this is just letting you check your work as you're going so you don't get to the end and find out you screwed up all of it. Because that would be no fun, right?
No fun.
But there are questions like this on your test.
Oh, that's fun.
I know, right? But then there's questions where you actually have to do it and stuff.
Yeah, that's easy.
Okay, I'm going to teach you a little bit of how to get the numbers for the rest of it today, and then we'll worry about graphing next time, because the how you get the numbers is where you have to do what your quiz was 2 times all the time. It's going to be a great time. Questions on this part? Sketching is fine.
Yes.
Sketching is never fun. That feels dramatic. Okay. So we're going to talk about how you actually graph these. And you're not going to actually graph them today with a equation, but you're going to start finding me more points. And what you're going to find for me every time is your zeros, which you already know how to do. That's what you did on your quiz. You are also going to be able to find for me those relative extrema or turning points, because it lets you play a really fun game of connect the dots. And so that's what I'm going to teach you how to do today. Miss Williams came to school today. Okay, to find relative extrema, you technically have to be able to do calculus. So I'm going to teach you, if this is like day 1 of calculus, it's probably a little day further than that, but it's fine. And it's going to teach you how to find that. In calculus, what they do is they find integrals and derivatives. And integrals and derivatives just kind of undo each other. But what derivatives do is they find you the slope at any point along the graph. Okay? Where that is helpful. So what I'm going to draw for you is just a random graph. No, not. What we're wanting to find is our turning points, yes? If you can figure out the slope at those turning points, it actually makes it really, really easy. What's the slope of the graph at both of those points? You had to draw a line through it that would kind of mark your slope. What would it be? What you whispered was good. So it would be horizontal, yes?
Yeah.
Okay? We could draw a line here that would mark my slope, and it would just be flat. Do you agree with me? Okay? What you're going to look at when you get to calculus is like the slope right here, say, is a pretty steep positive slope, yes? But at every single turning point, your slope is 0. We agree with that. Okay, so we want to find where the slope is 0. If I can find that, then my life is pretty easy. What you do for that is you apply what we call, in calculus, the power rule. Okay, the power rule will find you what we call the derivative. So now you can start saying those words to your calc friends and make them think that you know calculus with them. Of your function, of your polynomial, we're only going to do polynomials here. Okay, that derivative basically gives you the slope of any point along the graph. Okay, the way that we do this, and this is easier to show you through an example than through words, because it gets real wordy and ugly. I'm going to make up a whole bunch of numbers. Let's see, 6x to the 4th plus 3x cubed minus 7x squared plus 1.
Wait, what's derivative?
It is how you, in calculus, find the slope of something. You find the derivative of it, and then it calculates your slope anywhere you want it.
Oh,
It's the like real watered down version of it. And since we want to find where the slope is 0, if we can find the derivative, what we're going to end up doing is setting it equal to 0 and do what we did last class again.
Okay.
Cool? To find the derivative of a polynomial, it's a very repetitive process. I'm not going to explain why, because that is Mr. Bell's job to explain to you why it works. I'm just going to show you how to do it. The way that you do it, you take your exponent and you multiply it by the number in front. What's 6 times 4? Okay, when you do that, now you lower your exponent by 1. So what's 1 less than 4? 3. You do that to every single term. Okay? Take your 3, multiply by the coefficient. What's 3 times 3? And then lower 3 by 1 and throw your marker on the ground. 9x. Good. Okay? Take the 2, multiply it to the front. What's negative 7 times 2? And then it will be x to the just x, right?
X to the x.
X to the x. We're going to make these real ugly real quick. With this one, what is technically the exponent on my variable that you don't see?
0.
It's technically 0 because you don't see it, yes? So you would do 0 times 1, which is?
0.
So that constant will just go away. Your constants will always go away. Okay, this would be the derivative of my function, the way we do that. It's called f prime when you get to calculus. Okay, but that function will tell me the slope everywhere. What we will be able to do, if we want to know where the slope is 0, will I be able to set my equation equal to 0 then?
Yeah.
There we go. Okay, we're going to set whatever resulting equation we get equal to 0 and do exactly what you did to last night's homework. But it is going to find you your turning points instead of your zeros. We're going to do this a few times. Don't worry.
Okay. It went straight from squared to a constant. So like,
Because we didn't have an x term.
so is there ever gonna be an
Yes.
x term?
Yes.
So do you just?
So
do
like
times
say I
one?
had in here plus x.
Yeah.
We would have done 1 times 1, so this would be plus 1.
Okay.
Does that make sense?
Yeah.
I just frankly ran out of space, and so I didn't put one there.
Yeah.
Okay, so we're going to be able to set this equal to 0 and solve. This equation doesn't work because I winged it and made it up, so I'm not going to make you solve a super ugly problem. We're going to solve one I know works out. Cool? Cool.
Cool.
Like this one. And we're just going to find the terms of this one. We're not going to do everything. So So to find where my graph turns, this is where you have to find your derivative. You want to know where your slope is 0, because that's when my graph flattens out and goes the other direction. So we're going to apply the power rule to this equation. Okay, so that means that my derivative of this, what is 3 times 3?
9.
So this will be 9x squared minus, what's 2 times negative 7?
14.
So then it's just an x. On this negative 7, this is a 1. So 1 times negative 7.
Negative 7.
Good. And your x goes away. Your constant will always just vanish. Just how it goes.
Or
Okay.
constant.
Or constant. To figure out, this is the slope of any point along the graph. So in theory, you could find where the slope equal to any value. The only slope we care about is when the slope is 0. So we are going to set this equation equal to 0 and solve it. This is going to find where my graph, the x value is where my graph turns around. How do we solve that? Quadratic formula works. You can try to factor this, whatever you want. This goes back to last chapter and everything you already know how to do. It's just uglier, yeah, because you had to get this first and then do all this other stuff. How do we want to solve this one? Okay, cool. Gentlemen. So your x is 14 plus or minus the square root of 14 squared. See, minus 9. No. I should write a 4 there. 9 will go there eventually. All over 18. What do you get for the number under the radical?
448.
Wait, what?
4. Oh, yeah.
Sorry, do we agree based on the what? No, I'm not sure that we agree.
No, I agree.
You agree?
Cooper's confused. No, I'm not. Jay's not confused anymore. You're putting thoughts in a
We all got
microphone. I'm sorry,
448?
Cooper. Disrespect.
Okay. What Ms. Schlitt and I decided to do, because we are so nice, because you're graphing this, I'm not going to force you to simplify that radical. Because you are graphing, you have permission to just get those numbers out and round to the nearest tenth is fine. Okay? So do we know how to get those numbers out of our calculator?
What?
Yeah. So you're going to do 14 plus the square root of 448, hit enter, and then divide by 18. So we'll go with 1.95.
100.
And
3.1.
Yeah.
1.92652.
What is 14 minus square root of 448? Enter, divide by 18.
Negative 0.398.
Sure. Yeah. Round something like nearest tenth. Keep a couple decimals. What you're gonna have to be able to do is approximate this number on the graph. So frankly, with this one, I'm gonna get real close to 2. With this one, I would just go like in the middle. Okay? Just be able, with whatever your numbers are, be able to approximate it. For today, this is how far I want you to go. You're going to figure out where your graph turns around and tell me that's where it turns around at. You are going to be able to figure out the ordered pairs later and actually graph this. Today, I just want you to be able to find it. So this is the x-coordinate where my graph either has a maximum or a minimum. If I had my eye, wait.
But wait,
Come on, Amy.
But wait, there's more.
there's more.
But wait, there's more. Because what I want to show you.
Is I brought my remote instead of my
Just
calculator.
freaked out. Okay.
Just demonstrate.
If we go to Desmos, I'll be able to show you that I'm not full of crap.
Decimal.
Thank you for just, blanket believing me. What's the equation of the original?
3x, 3.
Minus, yep, 7x squared. Okay, so this graph has a maximum, and this number right here, if you can't read it in the cheat sheets,
Plus
cheat sheets,
3.
is the negative 0.398, which is exactly what we found. Yeah.
Plus 3.
What?
Then way down
This
here
is insane. This is
is
insane, guys.
1.954, which is also exactly what we found. Okay, you're going to be able to find those y values real easy next time by just plugging them into your original function. But right now, I just want you to be able to find where is it turning. That's what we just found.
That's
Epic. That's what I was going for. Super duper epic. Okay, questions?
No.
Do we see where these problems might get kind of long? That is the biggest problem with these, okay? But it's all kind of repetitive. What we're gonna do is just talk about how you would solve this one and find me the zeros and the turning points. Okay? We're gonna do it both exactly. Do we want steps for this?
So are we actually graphing these?
Today, no. Next time, yes.
Okay.
And so, like, if you want to graph it today, you have all the ability to. I just want to take a day by itself to graph with you instead of like, good luck, bye.
Graph. I like the
me.
sound of that.
What?
Waiting an extra day.
Oh, yeah.
Graph with me. Okay.
Now,
Yeah, exactly. So
you're
we are
finding
first. Okay, the first thing you're going to do is what your homework was last night. You are going to use rational root theorem, factoring, quadratic formula, whatever it is, to find all of your zeros. So we're going to set it all equal to 0. Yep. And this is where it will be helpful to like label and kind of separate your work, because since it all looks the same, it can get kind of confusing. Today probably 3. It'll get longer. Don't you worry. But we're pretty much only doing this the rest of the chapter, just in different variations. Oh, okay.
Yeah. All right.
It's fine.
It's
That's
easy
alright.
now. It's easy.
Okay. Can I factor that at all?
I mean, you could.
Oh, you can just get the next.
Yeah, take an X out if you can. Let's lower this thing. Okay. Then, remember now you're only paying attention to the inside stuff. Can I factor that?
No.
Yes.
Yes.
What?
No.
Let me change the question. Do we want to do rational root? Do we want to factor? Do we want a quadratic formula? Okay.
Yeah.
So, your rational root theorem tells you to find all your possible zeros. What are my possible zeros for this? Yeah. It's only plus or minus 1, right? Factors of the last, factors of the first, just a 1. So, whether you plug it in or you synthetically divide in, find me one of those that goes in.
Okay.
You keep finding it.
I
Don't
will.
let him steal your sunshine. Okay, but then you are.
One.
1 goes in?
Yep.
Cool. Glad we agree now. 1, 2.
See, let me take that. Let me get that quadratic formula of that.
So my resulting, so now if I write it all in factor form, I have this x. How do I write this 1 in a parentheses?
1 in a parentheses.
X minus 1. Good, you always flip that sign. And then this new part will be x squared minus 2x plus 1. Now we just have to solve that remaining part. Factor, quadratic formula, rational root. What do we want to do?
Quadratic.
It doesn't matter. Okay, up here I'll factor since most of you are saying factor, but you can quadratic formula, do whatever you want. What multiplies to 1, to save space on the board since I don't have it, what multiplies to 1 and adds to negative 2? Good. So when I factor this, you write it all the way out, factor by grouping, all that good stuff, what will this factor as? Yeah, you'll have 2x minus 1's there, yeah? Now you have 3, correct? setting each of these equal to 0 to get your actual 0 values, what will x equal? 0, and then 1 with a multiplicity of 3. While you're doing this, I strongly recommend thinking it through and processing so that next time when you graph, it'll be easier. That at 0, will my graph cross or will it like rebound and go back through? It will cross because it has an odd multiplicity. It has a multiplicity of 1 since I got that answer one time. Will the 1 cross or turn around? It will also cross because 3 is odd. Cool? Alright, so think about that chart as you go through it.
Where does 0 come
From doing this one.
from? Oh.
So it's not the actual number, it's how many times it.
So you care about both because you're going to put a dot on 0 just like we did on those sketching ones.
Yeah.
And then when you draw it, you're going to go through at 0 instead of turning around at 0.
Okay.
Yes, sir.
Where'd you get the multiplicity?
So because I got 1 from here and then 2 times here. So you would set x minus 1 equal to 0. And then this gives you really 2 x minus 1s, right? So you would set x minus 1 equal to 0 3 times, which means I would get the answer positive 1 3 times. Does that make sense?
Yeah.
Cool. Okay. Then, once you find max, you will apply the power rule and find your turning point, your relative extrema. Not a lot, because it takes this long. I think on your test it's literally like, here's 2. Because of that.
After you apply the power rule, you just go back to the same thing. Like
Yep, now I'm going to do power rule to this, and then I'm going to do the same thing all over again. Yes. I have to take the steps away because it's not letting me scroll. Okay. This is why I would separate it out. So this will be your turning points. And you are going to do the power rule to that equation. So your derivative is really, what, 4x cubed minus 9x squared plus 6x minus 1. And you have to do the same thing all over again. Yeah, and then you sigh about it a lot. Moving it so it's bigger. Okay, so now you have to do the same thing all over again. You have to either use your rational root, you factor, you quadratic formula, whatever is possible. What's my only option here?
rational root.
Rational root. Good. So you're doing plus or minus, what are my options?
1.
1 and? And? For the sake of time, I'm going to look up what my answer was last time.
I think this was.
But if you can find them before I find it.
1. It's 1.
1 goes in? Cool. So when we synthetically divide 1 out, I was like, that's 43, so I don't know. 1 goes in, so 4, negative 9, 6, negative 1. We got 4, we got negative 5, 1, 0. No, but it will be 0. So we divided out the 1, and now I'm left with 4x squared minus 5x plus 1. Now you have to solve the rest of it. How do I solve that back part? Factor, rational root, quadratic formula. Factor. And you can factor that. Multiply to 4 and add to negative 5 is what?
Negative 4, negative 1.
Good.
Come up in 50 minutes.
So what would be 4x minus 1 times x minus 1? We agree with that? Right, so then, whatever x values you get for this is where your graph turns around. Where will my graph turn at? And? this just has a, yeah, and we'll talk next time about what that does, because it does again do something funny. But I will show you that next time. Right now, I just want you to be able to get that. So again, your graph turns around at 1 and 1/4. Let me find, I'll pull up Desmond's again, so you can see that I didn't just make this up. What was this equation?
X to the fourth minus 3x to the third, is 3x squared minus x.
Okay, so this graph is all really crammed in right there. Okay, at 1, it both crosses, which we found it was a 0, and if you notice here, see how it flattens out? This is, again, we'll go into detail next time, but this is what happens if you have a higher multiplicity with your turning points, is it just kind of flattens and keeps going. But we'll talk about that in detail next time. Okay, right now you just have to know that that does happen. 0.25 is the fourth that we found, and that's a relative minimum. And then it also crosses at 0, which is what we found. Okay, that is everything you found. Next time you're going to graph it. Today you're just going to find it. Yes, sir.
So on the first part, we did the first part of the equation to find the zeros, and then
Yes.
we did the second part to
To
find,
find the terms, yes. So like this is the 1 and the 1/4. This is where your slope is 0. And then your zeros are that first part, yes.
That's why we did it twice.
Yes, exactly. Okay, they won't always work out pretty like this one. You will have to get decimals and quadratic formula. Don't worry about that. That's part of why I give you your answers on your homework.
Got it. Goodbye, everybody.
Bye, guys.
Good luck.